We're going to take a look at section 9.3 today. And what this is going to cover is it's going to cover slope. So we're going to learn how to calculate slope if given 2 points, or how to count out slope if we're looking at an equation or if we're looking at the line of a graph. So some of the things that we need to learn first, or that we need to remember, is that slope is also known as the rate of change of a line. Okay, with linear equations, we are always going to have a constant change with our slope. So between any points on the line, we pick any 2 points, and it should have the exact same slope. So that's why we call it the rate of change, because it's going to be the same no matter which points we go through. The other thing that we're going to see is that rate of change, or slope, is always the rise over the run. This means that it is always going to be your y values over your x values. Okay, so y is always on top, x is on the bottom. So rise, think about it in the sense that if you have your coordinate grid, you always have to rise up or down along the y-axis before you can run on your x-axis. So you always want to move up and down the y-axis first prior to being able to go along the x-axis. Okay, so it's your vertical change over your horizontal change. So the equation that you use to calculate, so if I give you 2 points, your equation is going to be y2 minus y1 over x2 minus x1. There are a couple of different types of slopes, and I do have some pictures for these on the next few pages, so please don't feel like you're not going to understand it. You're going to get to see those pictures. But we have a positive slope, which is going to rise up and go from left to right. So as you're reading across the graph, it's going to slope upwards, kind of like you're going up a hill if you're running up a hill. Negative slope, if you were coming down a hill, it's going to slope from the left to the right, coming down. So think about going up a hill, coming down a hill. Horizontal line goes straight across, just like the horizon, and that's going to have a slope as 0. So your slope m value is equal to 0. So remember, the letter m is typically used when we use a variable to define slope. Vertical lines going up and down, we call that slope undefined. And we're going to see when we calculate it what exactly causes that slope to be undefined. One of the things I know you guys really enjoy doing, word problems. I want you to be able to solve word problems using linear equations, having 2 variables, so 2 unknown values, and also be able to solve the slope, which again, in word problems, you're mostly going to hear the words rate of change. So just remember, those 2 things are interchangeable. So slope and rate of change are words that can be completely interchangeable as you're working with it. Okay, so I want you to remember that, because sometimes students will forget, and as they move on from slope to rate of change, they kind of get confused. So here are those pictures that I was talking about. Remember, positive slope from left to right going up a hill, negative slope left to right coming down a hill. If your slope is equal to 0, horizontal, straight across. And if your slope is vertical or undefined, it's going to go up and down. Again, I told you we'll look at the calculations on some of those to see how those are different. So when we talk about slope of a line, what we're talking about is the steepness of it, like how fast does it rise or how long does it take to go up. And you can think about that in the sense of like any type of hill. If you run, or if you're driving a car, or if you ski, you want to know the steepness of the hill, and that's called the slope. So it's, again, going to be for any 2 points, rise over run. So the y values over your x values. So you're always going to count on your y first, which is your top number, and then on the x-axis for your run, your second number, the bottom number, okay? So here's a picture of a line for slope. It's a positive slope because we're going from left to right. We're going up the hill. And what we want to know is, what is that rate of change? So if we're looking at this slope, we can look at it and say, well, here's the rise. It goes up. How many units does it go up? It goes up 2 units, right? Because we come from 1 and we count up 1 unit, where here is 2. And then our other unit is here, which is 3. And then how does it run? Well, it runs this way. And how many units? We start at this unit here, okay? And we're going to count over. So it goes 1 unit, 2 units, 3 units, and it goes to a 4th unit. So our rise is going to be 2, and our run is 4. So we would write this as a fraction of 2 over 4, but then as with any fraction, we want to simplify it. So if we simplify that, we would get 1 over 2. And again, it's a fraction, so we want to write it 1 over 2. So actually, we could even see that if we wanted to. If we counted that out, we could count up, and I'm going to use this bright green, so we could count up 1 unit, and then if we count over 2 units, we're right here on the line, so it's true. Okay, so it goes up 1 unit and over 2, or we can count up 2 units and over 4. It's the same thing. So we know the rate of change between unit 2 and unit 4 is the same thing as the rate of change between 4 and 6. So they are equivalent as we move. So anytime we move along the line, we should have equivalent values as we move for that slope. Here's another example, and this one is a negative slope moving down and to the left. Again, we want to do our rise over our run, and this one's negative. So we have to count down the y-axis to count it, okay? So we're going to count down, and we count down how many units? 1, 2, 3 units, okay? So this right here is 3 units. Oh, it's not really a very good color. Let me change it to a darker color so you can see that. So 3 units, okay? And then when we go across, we go 1 unit, we go 2 units, 3, and it's 4 units. So as we count across, we count 4 units. So if I write this as a fraction, I'm going to write that m equals 3 over 4, and again as a fraction. So it rises 3 over 4. But notice as we count this, we're counting down. And if we count down on the y-axis, it's always negative, right? So we need to have that negative out front, which requires us to have this negative out in front of here. So our slope is actually a negative 3 over 4, okay? So we don't want to forget that because we're counting negative down and then positive across. So one of our numbers is going to be negative and the other one's going to be positive. Now, if we counted both numbers negative, our slope is going to end up turning into positive, because if you have a negative, let's say 1 over a negative 4, the two negatives become positive, so that would become a 1 over 4. So it's the same rules with our slope as what we have with any other fractions. Okay, just remember when you count down this slope, it's a negative 3, not a positive 3. So we want to make sure we include that, and we don't want to skip over that in the positive form, the bottom. So when we're finding slope, if we have 2 points, we want to label them x sub 1, y sub 1. So those are just our points on our first coordinate point, our first x, our first y. And the second point, we're going to call it x sub 2, y sub 2. And that's just so that we know how to plug them into the equation properly. So our slope formula, remember, this is m here. So m is equal to y2 minus y1 over x2 minus x1. Or we can call it our change in y over our change in x, where rise is over run. So all of that is all the same. Okay, and that stuff doesn't change. It's all equivalent, all interchangeable. Remember, slope, rate of change, or the difference between y2 minus y1. Now, if you put in y1 minus y2, you just have to remember to do the exact same thing on the bottom, x1 minus x2. So the order is going to matter, but you never want to switch your x and your y, because then you will have an incorrect slope. So you always want to keep the y's on top and the x on the bottom. You can change the order. I personally always say y2 minus y1, just so that I don't mess up those equations, because if you look it up to try to verify, you're always going to see it set up that way, y2 minus y1. All right, so here's an example for finding slope. So we want to find the slope of the line that passes through the points -2, -2, and 4, 1. Now what I always do when I do these is I label them. And I label them as x1, and I usually do this right below it, x1, y1, and then x2, y2. I do it here, and it's hopefully going to come out with the mouse pad, but I can't promise. X2, Y2. And then that way there you can plug the values in. They wrote them out here to the side. You can do that if you want to, but I always just write it right underneath, and then it's easy for me to plug in. So my Y2 is a positive 1. My Y1 is a negative 2. My X2 is a 4, and my X1 is a negative 2. So now I just follow my rules of order of operations, and a double negative becomes a positive. So 1 plus 2 on the numerator, and the bottom 4 plus 2 on the bottom, because the double negatives become positive. So I end up with 3 over 6. Again, always simplify 1/2. Okay, so always label if it helps you. Sometimes it might help you if you want to use highlighters to highlight your Y2, Y1. You can separate them if you want to, or if it's just as easy for you to write it here, you can write it here. The key things to remember is to keep your signs organized, because if you drop a negative, you can change the whole value of your slope, and instead of being a positive slope, you might end up with a negative slope. Or sometimes reversing your numbers. So that's why I label them, because when I label them, it makes it a lot easier for me to follow so that I don't accidentally put them in the wrong order. So you just want to make sure you follow that process, okay? So again, I always label them X1, Y1, X2, Y2. So then I know exactly where they go in. And whenever you see me do a problem, I will always do that. So on answer keys, you're going to see that I hand write out. You're going to see that I always set up this formula first with all my labels, because it's much easier to follow and to see if I made a mistake. So horizontal lines, remember these go straight across, and you have a slope m is equal to 0. So this is one where if you do your calculations and say you end up with a 0 in the numerator, that is fine, because 0 divided by any number is always equal to 0. So we don't care what 0 is divided by. So as long as 0 is in your numerator, you can do this. So you don't have to worry about that. On the flip side, though, the vertical line, if we do a vertical line, this is where you're going to end up when you do your calculations. You might end up in the opposite situation where you have 2 divided by 0. And we've talked about this one before. You cannot divide any number by 0. If you plug that into your calculator, you're always going to end up with an error. And whenever you see that error come up, it's always undefined. I remember it as saying 0 under, undefined, because it kind of goes together. So as soon as I see that 0 in the denominator, I always say it's an undefined value. So I'm not going to use it. I have to say it's undefined, and it goes straight up and down. You don't want to say there's no slope. There's a difference between undefined and no slope. So don't say there's no slope, because that's not correct. But you always want to remember there's a difference between a 0 slope, which is horizontal, and an undefined slope, which goes up and down. So this is just a quick review. You guys should have seen slope before in Algebra 1. So it's just a quick review of the calculations of slope and the definitions of slope and how you would get it. If you have any questions, definitely reach out and let me know. Otherwise, next one is going to be going on. I'll post another video for section 9.4.